Hi, welcome back, everyone. We'll see some more problems. Yesterday, we have discussed some of related on Fourier series, and I've done only the theory part of that. I just talked or discussed about that. Let us see some of the problems related to Fourier series, and then afterwards, further, we'll look into some of the problems related to Newton-Raphson and then how it goes. Okay, let us see. Let us try to explain you uh, some of the examples on Fourier series. Okay, suppose if I have a problem that is f of x is equal to x sine x. Okay, so yesterday we have already discussed on the function, how you have to look into that, and whether it is a even function or odd function and so on. Okay, we have already discussed on those topics yesterday, and the interval uh, corresponding to it. Okay, suppose if I have a function which is f of x is equal to sine x. Let us find the expansion for or the terms related to that. Okay, expression for that over the which is defined over the interval which is minus pi to pi, and also deduce that in the following, that is pi by 2 is equal to 1 plus 2 by 1, 1 into 3 minus 2 divided by 3 into 5 plus 2 divided by 5 into 7 and so on, as well as another deduction. Let us do that also. Pi minus 2 by 4 is equal to 1 by 1 into 3, and minus 1 by 3 into 5 plus 1 divided by uh, 5 into 7. Okay, and so on. Okay, now let us do the problem. Uh, for the function which is f of x is equal to x sine x. Now, to check whether it's an even function or odd function, let us put x as minus x here. So when you substitute it, so I get minus x sine of minus x. You are substituting on the whole for the function. So minus of minus. So this becomes plus. That is how minus sine x you have substituted it, and sine of minus x becomes minus sine x. So minus of minus, then this becomes plus. So you get the function which is x sine x. Now the given function is also x sine x. So you got back the same function. So you got the function that is an even function. Fine. So this is done. Now, now once you find that it is an even function, okay, your Fourier coefficients are there. That is a naught, an, and bn, and if required a1, b1, you can find. So suppose I have those Fourier coefficients. So if since it is an even function, we can neglect bn function, which is a coefficient, Fourier coefficient, that is that goes to zero, since it is an even function. So we need to find the Fourier coefficients. Those are a naught and an. Let's find that. Now, the general formula corresponding to that, the function becomes f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x by L. Now, L being pi, so pi gets cancelled. So you get only cos nx. So finally, you arrive at to the function itself, that is f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx. Okay, what is the Fourier coefficients? So what is a Fourier coefficients? So Fourier coefficients are a naught, a1, a2, an, and bn, and so on. So those are Fourier coefficients. Okay. Again, let us find what is a naught. The formula corresponding to that a naught is 2 by pi integral 0 to pi f of x dx. Okay, so f of x being x sine x. So you get, that is 2 by pi integral 0 to pi x sine x dx. Okay, so x and sine x, so u into v. Okay, so 2 by pi, again, let us find x sine x. So x integral sine x dx minus d by dx of x and double integral of sine x dx over the interval 0 to pi. Okay, so since it is an even function, you have 2 by pi. That's what I want to mention about that also. Now once that is done, integration of sine is minus cos x. Okay, double integration of sine becomes minus cos x, and differentiation of x becomes 1. So when you try to simplify all those things, you get 2 by pi x into minus cos x minus 1 into integral of minus cos x dx over the interval 0 to pi. Fine. So once that is done, okay, let us again sub substitute it. Again, integration of cos becomes sine again. So 2 by pi, again, minus uh, x cos x plus sine x over the interval 0 to pi. Now let us substitute the intervals which is 0 to pi. Okay, now we have the two functions here, two terms here, x cos x and sin x, keeping negative outside. Okay, let us substitute uh, the first interval, which is pi. Okay, when you substitute it, and 2 by pi is still outside, so minus of pi cos pi minus 0. Since the upper limit is pi and the lower limit is 0, I have substituted it. Okay, plus sin pi minus sin 0. Fine, did you understand this? We'll move on to the next part of the problem. Now what happens for cos pi? We know the general term for this is cos n pi is minus 1 to the power of n. So substituting n is equal to 1, cos pi will be minus 1. And of course, for sin n pi is also 0. Sin pi will be 0. Substitute these values. So we arrive at to, after simplification, we get 2 by pi minus pi of minus 1 plus 0. So cancel all this pi and pi. So you will be left with a naught value, which is 2. Fine. Okay. Now let us find what is an. An is 2 by pi integral 0 to pi f of x cos nx dx. Fine. Since L is pi, so pi pi gets cancelled. You get n x dx. Now n pi is equal, an is equal to 2 by pi integral 0 to pi f of x being x sine x cos nx dx. Fine. Now uh, let us put for n is equal to 1. You'll get a1. That is the first Fourier coefficient, okay, which is a1 is equal to 2 by integral 0 to pi x sin x cos x dx. Now, uh, sin x into cos x becomes, if you again you have by 2, so 2 gets cancelled. I can substitute as sine 2x. So ultimately you will get as 1 by pi integral 0 to pi x sine 2x dx. Now integration of sine mx dx is minus cos mx by m. Okay. Now again this is u into v. Let's do that. So 1 by pi x integral sine 2x dx minus differentiation of x and double integration of sine 2x dx. Now differentiation of x is 1. Again double integral of sine 2x becomes minus sine 2x divided by 4, and integration of sine 2x becomes minus cos 2x by 2. Okay, have you done it? Yes, that is the formula which we have discussed. That is integral sine mx dx is minus cos mx by m. Okay, that is the one which we have done. Now let us substitute the limits, which is 0 and pi. Now when you substitute pi, so this becomes pi cos 2 pi minus 0 plus 1 by 4 sine 2 pi minus sine 0. So sine 2 pi becomes minus 1 to the power whole square, which is 1 again. Sine n pi is 0. Sine 2 pi will be also 0. So let us substitute all the values which you got. Okay. Now once you substitute those values, that is a1 is equal to 1 by pi minus 1 by 2 into pi. Okay, pi gets cancelled. So a1 will be minus half. So a1 is minus half. Fine. So again, let us find what is an. An is 2 by pi integral 0 to pi x sine x cos nx dx. Okay. Now we have the formula for sine a cos b, which is 1 by 2 times that of sine a plus b plus sine a minus b. Okay. Now let us substitute what is a plus b and a minus b. A plus b will be n plus 1 into x. A minus b will be minus of n minus 1 into x. Now let us substitute those things which I have discussed. Now an is equal to 2 by pi integral 0 to pi x into 1 by 2 of sine n plus 1 and minus sine of minus x becomes minus sine x. So if I take minus outside, so I get only sine of n minus 1 into x dx. So 2 gets cancelled. So I'll arrive to this as 1 by pi integral 0 to pi x into sine n plus 1 into x minus sine n minus 1 into x dx. After that, let us uh, substitute the values, which is pi and 0. Now this is again separately uh, n plus 1 you have x into sine n plus 1 you have, and you have x into sine n minus 1 you have. So u into v and u into v again. Okay, you have both the terms here. Again, let us integrate it. So x into integral of sine n pi n plus 1 into x dx minus differentiation of x is 1 double integration sine of what is it n plus 1 into x dx. Okay, as well as n plus, we have n plus 1 also, as well as we have n minus 1 also. Let us do that also. So for n minus 1, so it is x integral sine n minus 1 into x dx minus differentiation of x is 1 double integration of sine n minus 1 x dx over the interval minus 0 to pi. Okay. Now, once that is done, now integration of sine n plus 1 into x is minus cos n plus 1 x divided by n plus 1 minus double integration of sine becomes minus sine n plus 1 into x divided by n plus 1 whole square. Okay. This is for the term which is n plus 1. Now let us see for n minus 1. Integration of sine n minus 1 x will be minus cos n minus 1 x divided by n minus 1. Again, double integration of that will be minus sine n minus 1 x divided by n minus 1 whole square over the interval 0 to pi. Okay. So once that is done, try to simplify it further and then let us substitute the value. Now once you have done this, okay, let us see the last step which we have done. So that is again, that is 1 by pi x into minus of cos n plus 1 into x divided by n plus 1 plus cos n minus 1 x divided by n minus 1 plus sine of n plus 1 into x divided by n plus 1 whole square minus sine of n minus 1 x divided by n minus 1 whole square over the interval 0 to pi. That's what we have done. Okay. So we have to look into cos n plus 1 into pi and cos n minus 1 into pi. Okay. So for n plus 1, you will have minus 1 to the power of n plus 1. And for cos n minus 1 pi, you will have minus 1 to the power of n minus 1. So sine n plus 1 pi will be 0, as well as sine n minus 1 pi will be 0. So let us substitute all the results which we got. Okay. We have an is equal to 1 by pi brackets minus pi divided by n plus 1 cos of n plus 1 into pi minus 0 plus pi divided by n minus 1 cos n minus 1 pi minus 0. Okay, let us substitute what is cos n plus 1 pi and cos n minus 1 pi. That is, finally, if you look into the numerator, you have pi as common, and denominator being pi gets cancelled. And if you take minus outside, so you got minus 1 divided by n plus 1 into minus 1 to the power of n plus 1 plus 1 divided by n minus 1 to the power of minus 1 to the power of n minus 1. So we get this result. And then after continuing this, okay, now minus 1 to the power of n plus 1 can be written as minus 1 to the power of n, as well as for minus 1 to the power of n minus 1 can also be written as that is minus 1 to the power of n minus 1. Okay, so that results to 1. So you can take on the whole as minus 1 to the power of n minus 1. Okay, fine. Now an will be minus 1 to the power of n minus 1 into minus 1 divided by n plus 1 plus 1 divided by n minus 1. Okay, so let us simplify that also. Further, you get an is equal to 2 times that of minus 1 to the power of n minus 1 divided by n minus 1 into n plus 1. So this is an. Okay, now let us substitute what all the results or the coefficients you got, that is a naught, a1 and a. The function is now f of x is equal to a naught by 2. Since we have got for n is equal to 1, let us substitute that also, plus a1 cos x plus summation n is equal to 2 to infinity an cos nx. Okay, so a naught we got the value which is 2, a1 we got that as 1 by 2 minus 1 by 2. Let us substitute it. So you get the function which is f of x being x sine x is equal to 2 by 2 minus 1 by 2 cos x plus summation n is equal to 2 to infinity into 2 into minus 1 to the power of minus 1 n minus 1 divided by n minus 1 into n plus 1 cos nx. Further simplification, I get x sin x is equal to 1 minus 1 by 2 cos x plus 2 times that of summation n is equal to 2 to infinity minus 1 to the power of n minus 1 divided by n minus 1 into n plus 1 cos nx. Now we got this result, and furthermore, when you try to expand that by substituting n is equal to 2, 3, and so on, when you substitute all those things, we get the further series x sin x is equal to 1 minus 1 by 2 cos x plus 2 times that of minus 1 divided by 1 into 3 cos 2x plus 1 divided by 2 into 4 cos 3x plus minus 1 divided by 3 into 5 cos 4x plus 1 divided by 4 into 6 cos 5x and plus minus 1 divided by 5 into 7 cos 6x plus so on. So this is the expression which we get now. Now once we find this, let us deduce into uh, we have to arrive into pi by 2. The given question we have, which is pi by 2 is equal to 1 plus 2 by 1 into 3 minus 2 divided by 3 into 5 plus 2 divided by 5 into 7 and so on. Let us get that result also now. Now, how do we get this? Now, x is defined over the interval minus pi to pi. Okay, so let us take x value as pi by 2. Let's substitute it. When we substitute x is equal to pi by 2, now sine pi by 2 is 1. So on the left hand side, when you substitute it, you get only pi by 2 alone. Since you have the function as f of x is equal to sine x, so x being pi by 2, so pi by 2 into sine pi by 2. So sine pi by 2 being 1. So in the left hand side, you'll get only pi by 2. Let us concentrate on the right hand side of the equation or the expressions. We get, when you substitute it, okay, 1 minus 1 by 2 cos pi by 2 plus 2 times that of minus 1 divided by 1 into 3 cos into 2 into pi by 2 plus 2 divided by 2 into 4 cos 3 into pi by 2 plus 2 into minus 1 divided by 3 into 5 cos 4 into pi by 2 and so on. Now we know that cos sine pi by 2 is 1, cos pi by 2 is 0, cos pi is minus 1, cos 3 pi by 2 is 0, cos 4 pi by 2 is cos 2 pi, which is equal to 1. Cos 5 by 2 is again 0. Again cos 6 pi by 2, which is cos 3 pi, which is minus 1. So let us substitute all these results which we got. So once you substitute it, I get pi by 2 on the left hand side. Okay, is equal to 1 minus 2 divided by 1 into 3 minus 1 minus 2 divided by 3 into 5 into 1 minus 2 divided by 5 into 7 minus 1 and so on. Now further simplification of this will be pi by 2 plus pi by 2 is equal to 1 plus 2 divided by 1 into 3 minus 2 divided by 3 into 5 plus 2 divided by 5 into 7 and so on. So we got the result which is pi by 2. Fine. So we got the first result. Now the next result is we have to get pi minus 2 divided by 4. Okay. So what you are supposed to do is on the right hand side you have 1. Take it to the left hand side. So you get pi by 2 minus pi 1 is since 2 is common for all those the series, so take it that as common. So 2 into 1 divided by 1 into 3 minus 1 divided by 3 into 5 plus 1 divided by 5 into 7 and so on. Okay, so once that is done, okay, now take 2 on the left hand side. So you arrive into this expression, that is pi minus 2 divided by 4 is equal to 1 divided by 1 into 3 minus 1 divided by 3 into 5 plus 1 divided by 5 into 7 and so on. So hence we have got this result. Okay, what everybody has to remember here is when you look at this pi by 2 expression, this is very important. Now look at the denominators of the expressions here. First is 1 plus 2 divided by 1 into 3. Next 3 into 5. Next 5 into 7. And next would be 7 into 9 and so on. Fine. So you have only the odd ones here. 1, 3, 5, 7, 9 and so on. So those things you have to look into. Okay. So please try to remember this. Okay. So let us move on to next problem. Okay. Now the problem I'll be discussing now will be on Newton-Raphson's method. Yes, thank you also. Now let us look into Newton-Raphson's method. Now applying Newton-Raphson's method to find an approximate root of the equation. So what you are trying to solve here is you have to find the root of the equation. That's it, by using Newton-Raphson's. That's what you are trying to do here. Okay, let me complete the question. The question is you have to find the Newton-Raphson's method to find an approximate root of the equation, which is x cubed minus 3x minus 5, which lies near x is equal to 2. Okay, that is the the value itself he has given. Okay, so let us solve this equation. Now, to solve this equation, let us put that the function which we mentioned here is x cubed minus 3x minus 5 should be equated to 0. Okay, once we equate that to 0, okay, now here in Newton's Raphson's method, you have to first find the differentiation of that function, that is f dash of x. Differentiation of that function, which is x cubed minus 3x minus 5, will be 3 times that of x square minus 1. Okay, once that is done. Now the formula corresponding to Newton-Raphson's is x k plus 1 is equal to xk minus f of xk divided by f dash xk. So this k will be for 0, 1, 2, and so on. These are the approximation. First approximation, second and third and fourth and so on. That will be x1, x2, x3, x4 and so on. Okay, so let us do that. So the general term corresponding to that will be, when you substitute k, that will be x cube k minus 3xk minus 5 divided by 3 times that of x square k minus 1. Okay, so further simplification, if you do it, we arrive into 2 times that of x cube k plus 5 divided by 3 times that of x square k minus 1, for k is equal to 0, 1, 2 and so on. Now since he has given the near root, which is x is equal to 2, okay, let us take x naught as 2. Okay, now substitute for n is equal to 0. So x1 will be 2 times x cube x naught plus 5 divided by 3 times that of x square x naught minus 1. Now substitute these values. So when you substitute these values as x naught as 2, I arrive into this solution for this will be 21 by 9, which is equal to 2.33 and so on. So we got the first, that is first approximation, which is x1, which is 2.33 and so on. Now let us substitute for k is equal to 1. So you get x2. So 2 times x cube x1 plus 5 divided by 3 times x1 square minus 1. Okay, now let us substitute what x1 you got, that is 2.33 and so on. Let's substitute that. So once you substitute it, you get the value as 2.28055. Let us find the next approximation, x3, substituting it. I hope everybody is trying to uh, solve this. Okay, so again the formula becomes x3 is equal to 2 times x2 x cube x2 plus 5 divided by 3 times that of x square x2 minus 1. Let's substitute that. So we arrive into 2.27902, as well as x4 is equal to 2.27902. What we have to notice that x3 value and x4 value has uh, these values is nearly the same. So we have to stop this finding the next approximation. So Since it is identical, both x3 and x4 is identical, let us take the root itself as x is equal to 2.27902. So we arrive into the final approximation root of the equation, which is x cube minus 3x minus 5 is equal to 0. So this is the root of the equation which we get. Okay, so by using Newton-Raphson's method. Okay, let us see the next part of the problem. Newton's Raphson's method. Okay, let us find by using Newton-Raphson's method, find the approximation root of the equation x log x to the base 10 is equal to 1.2. Uh, Again, here the root is given, the value which is given as 2.5. Let us find that. Now, for whatever method we are trying to do, we have some other methods also. Try to solve or to find the root also. Okay, this is one type of method, which is okay. Let us again look into the problem again. So the function in the previous we had only the cubic expression. Okay, now we have logarithm here. Now what we have to look into this problem is you have log x to the base 10. Okay, we have uh, to again convert that in terms of e and so on. Okay, so let us find that also. Okay, now differentiation of this will be x into differentiation of we don't have differentiation of log x to the base 10. We have differentiation of log x to the base e. So differentiation of log x to the base e will be 1 by x. Okay, and log e to the base 10 plus log x to the base 10. So this results to, now we have uh, log e to the base 10 will be 0.43429 plus the base 10. So differentiation of the given function will be f dash of x is equal to 0.43429 plus log x to the base 10. Okay, now the first approximation, which is x1, is x naught divided minus f of x naught divided by f dash x naught. Let's substitute all those values. X naught being 2.5. Let's substitute it. Okay. So once we substitute it, okay, so we get the first approximation, which is x naught, which is 2.7465. Okay. Let us find the next. So you get x2 as x1 minus f of x1 divided by f dash x1. So let us substitute it again. X1 being 2.7465. Let's substitute that also. Okay. So once you substitute it, you get 2.7406. Okay. So that is done. Now, once we get this, okay, you got x2. Let us find what is x3. X3 will be x2 minus f of x2 divided by f dash x2. Okay, x2 being 2.7406. Let us substitute it again. So you get x3 06. Now, when you notice these two results is same, x2 as well as x3 is same. So these are identical. So we can consider uh, x, which is the approximate root of the equation, which is x log x to the base 10 is equal to 1.2. So which is correct up to 4 decimal places. Okay. So I hope you understood this problem. We'll continue to do this uh, live sessions and keep posting whatever you have. Okay. And thank you for listening. And solutions also will be provided once you send me the email, so that I can send you the solution for these problems which we have discussed right now. Okay. Thank you.